Welcome to this deep dive. Today, we're taking a pretty amazing journey off our planet. We're going to explore what happens to our brains when we leave Earth.
Yeah, it's fascinating stuff. We'll look at how space conditions, things like gravity, being far from home, how they affect not just the body, but, well, how we think, how we feel.
And even the brain structure itself.
Yeah.
Right, so our mission today is to really understand what space travel does to the mind, both right away and over longer trips.
Exactly. We've sifted through quite a bit of research, neuroscience findings, reports from actual missions,
Yeah.
to piece together this picture of the effects on thinking, emotions, even the physical brain, short-term, long-term, all of it.
In guiding us through this, we have an expert neuroscientist joining us, someone who's really focused on, well, how brains react in space. Welcome.
Thanks. It's great to be here. The brain is just incredible. And putting it in an environment like space, it really highlights how amazing, but also how sensitive it is.
So let's jump right in. When someone first gets into space, what's the absolute first thing their brain has to deal with?
Okay, so one of the biggest, most immediate changes is the feeling of no gravity, or, well, what scientists call microgravity. You see, here on Earth, our brain constantly uses signals from our inner ear to keep balance to know which way is up.
Right, the inner ear.
But in space, that constant pull of gravity just disappears. And the inner ear, it gets pretty confused.
Okay, let's break that down. Microgravity, that's like really, really weak gravity, yeah.
Exactly, very low gravity.
And the inner ear, that's the bit inside our ears for balance and hearing. So without gravity, what happens? What does that confusion feel like?
Well, the brain starts getting mixed signals. It's not getting the information it expects. And this can trigger something called space adaptation syndrome.
Ah, I think I've heard of that. Isn't it like being seasick?
Very much so. Like seasickness or maybe bad car sickness. Astronauts might feel dizzy, get headaches, feel nauseous. Some even feel like they're spinning when they're perfectly still.
Oh, wow.
Yeah.
That sounds not fun
Yeah,
at all. But they get used to it, don't they? I mean, astronauts seem to manage.
they do. You're right. The human brain is remarkably adaptable. That's a key word here. Adaptable.
Meaning it can change, adjust.
Precisely. Most astronauts find their symptoms ease up within, say, 2 to 3 days. The brain learns to rely less on the confused inner ear and more on other cues, like what they see or the feedback from their muscles and joints about where their body parts are. It recalibrates.
Okay, so that's the initial hurdle. The brain adapts. But what about longer missions, weeks, months in space? What happens then?
Well, that's where things get even more interesting and maybe a bit more surprising. We start seeing changes that are more structural.
Structural mean the actual physical brain.
Yes. Looking at brain scans from astronauts before and after long flights, we found evidence that the brain structure can change slightly. One finding is that the brain seems to shift. It moves upward a tiny bit inside the skull.
Wait, hang on. The brain moves. How does that even happen?
It seems to be due to something called fluid shifts. On Earth, gravity pulls body fluids downward. In microgravity, without that pull, fluids like blood and the cerebrospinal fluid around the brain tend to drift upwards towards the head. This change in fluid distribution seems to cause the brain to float slightly higher. When we say structure, we just mean how it's all arranged in there.
That's fascinating. And kind of weird to think about. Are there other physical changes they've seen?
There's some evidence suggesting the cerebellum might shrink a little bit.
The cerebellum. That's important for movement and coordination, right?
Exactly. It helps us make smooth, controlled movements. The theory is, in microgravity, you just don't need the same level of complex coordination for movement. You float. So maybe that part of the brain gets a bit less of a workout, and that could lead to a slight reduction in size. Still researching that one, though.
Okay, so the physical structure can change.
Yeah.
But what about thinking, memory, concentration? Do those cognitive functions get affected?
That's a really critical area, yes. And some astronauts do report experiencing what scientists call mild cognitive decline.
Mild decline. What does that actually mean for them?
It can mean things like slightly slower reaction times, maybe more minor memory lapses than usual, or finding it harder to multitask, to juggle several things at once. Cognitive, by the way, just means anything related to thinking processes.
Right. And what's causing that? Is it just being in space, the microgravity?
It's probably a mix of factors. Chronic low-level stress is likely a big one.
Chronic, meaning long-lasting.
Yes, exactly. Even for highly trained astronauts, being cooped up in a small space far from Earth in a potentially risky environment, It creates this constant low-grade pressure.
I can imagine.
Then add in potentially disrupted sleep, the usual day-night cycle is gone, limited social interaction with just a small crew, no natural sunlight. All these things can put a strain on the brain's ability to perform at its peak. Low-level stress is that kind of constant background hum of pressure.
It sounds like isolation could be a major factor, too. Being so incredibly far away, does that emotional side affect things?
Oh, absolutely. The psychological impact is huge. Being physically distant, the communication delays making real-time chats difficult. It can lead to psychological stress.
Psychological strain,
Yeah,
like mental pressure, emotional stress.
exactly. Loneliness, feeling disconnected. That can definitely affect mood, motivation, and yes, likely contributes to some of those cognitive issues too.
So, knowing all this, what do space agencies actually do to help astronauts cope?
They're very aware of this now. Modern missions build in a lot of support. Astronauts have scheduled video calls, not just with family, but with therapists too.
Oh, yeah.
They often use mindfulness apps, relaxation techniques, things to manage stress. And having very strict daily schedules actually helps provide a sense of normalcy and routine.
That makes sense. I also heard they sometimes use VR, virtual reality. How would that fit in?
Yes, that's a really neat countermeasure. They use VR headsets to simulate natural environments back on Earth.
Simulate.
Hmm.
Like create a pretend version.
Exactly. It creates the look and feel of, say, walking in a forest or sitting by a lake. The idea is to reduce stress, improve mood, give them a mental break and a feeling of connection to home.
Wow, I could see how that would help. I remember reading about an astronaut who said they just desperately missed seeing trees.
Precisely. It's often those simple, everyday things from Earth that you don't realize you'll miss until they're gone. That connection to nature is powerful.
But it's not all negative, is it? I've heard about something called the overview effect. That sounds more positive.
Ah, yes, the overview effect. It's a really profound phenomenon many astronauts describe. It happens when they see Earth from space, this small, beautiful blue marble hanging in the blackness.
What does it do to them?
It often triggers this overwhelming sense of unity, a feeling of connection to everyone and everything on the planet, a sense of Earth being a single, fragile system. Unity here means that feeling of being part of one big thing. It can be a very powerful, perspective-shifting experience.
So even with all the stress, the fluid shifts, the challenges, the brain can still experience this incredible sense of wonder.
Absolutely. It really speaks to the brain's capacity for awe and finding meaning, even under, the most extreme circumstances imaginable.
This has been absolutely fascinating. Thank you so much for taking this deep dive with us into the astronaut's brain.
It's been my pleasure. It's a field that's constantly evolving. We're always learning more.
Okay, before we wrap up, let's quickly recap some key points for everyone listening, especially if you're learning English with us today. We heard how the brain initially gets confused by microgravity, that lack of gravity leading to space adaptation syndrome, but also how incredibly adaptable it is.
Right, adaptable, able to change. Then we touched on those surprising structural changes on longer missions, like the fluid shifts moving the brain slightly.
And the cognitive challenges that mild decline some experience,
Yeah.
likely due to stress, isolation, and things like that, and the emotional strain.
But also the countermeasures. The support systems, the VR simulations to reduce stress. Simulate means to create something that feels real.
And finally, that amazing overview effect, giving astronauts a whole new perspective, a feeling of unity. Now, for our English learners, notice how we often use the present simple tense. We use it for general facts or things that happen regularly.
Like when we said the brain adapts, that's a general truth about the brain.
Or astronauts have video calls. That's something they do routinely, a habit during missions.
And some astronauts report cognitive decline. That describes something that generally happens for some people in that situation.
Okay, quick practice for you listening. Just think about the answer. First one, astronauts often feel dizzy at first. Is this something that happens sometimes or always? Pause. The answer is sometimes the word often tells us that. Second, they usually have video calls with family. Is this regular or rare? Pause. Regular usually points to a regular habit. Last one. The brain needs time to adjust. Is this a general fact or one specific event? Pause. It's a general fact about how brains work in new situations. Great. And let's review a few key vocabulary words.
First, adaptable, meaning able to change easily. Like our brains are very adaptable to new situations.
Next, microgravity. That very weak gravity in space. Living in microgravity can affect how our bodies work.
Then stress, that feeling of being worried or under pressure. Being far from home can cause stress for astronauts.
And simulate, to create something that looks and feels real. They use VR to simulate being on Earth.
Good one.
So, thinking about all this, just like the brain adapts to the extreme environment of space, remember that you are adaptable too. Learning English can feel challenging sometimes, maybe even like an extreme environment.
Yeah, sometimes.
But embrace that challenge. Keep exploring, keep learning, and who knows, maybe you'll experience your own kind of overview effect as your understanding of English expands and connects you to a wider world. Thank you so much for joining us on this deep dive.
Thanks for listening.
Next time, we're going to look ahead. How do we actually prepare the brain for even longer journeys? Think deep space missions, maybe even Mars. We hope you'll join us for that.